Hello, relativity friends. Um, some time ago, I bought this book off of profoundphysics.com, courses, the general relativity, and I did a review of this book on YouTube. I'll leave a link in the description. And it was, good and not so good. Had really great parts, some okay parts, and some parts I didn't really care for. But in general, it was useful because I use it as a reference. I'm always going back to it to look something up. If you're a beginner, this book's not for you. If you have already an introduction to general relativity, then it's good. Anyway, the point was the author of this book, he said, I'll give you this book if you will do a review of it. And I said, okay, fire away. And so he sent it to me, and I did a review, and I'll leave a link in the description. And when I did the review, the last two courses, which is the covariant derivative and differential geometry, were not available. Well, they are now. And I downloaded this one. Now, you can read this as a PDF on your computer as this, or you can download it. I chose to download them all. And let's take a look at it. Lesson 9, covariant derivative and parallel transport. Now, the covariant derivative is one of those the fundamental concepts in the calculus that you really do need to understand if you want to work in that field. Uh, it was developed by Ricci and Levi-Civita because they realized that the partial derivative, as an example, the directional derivative in curvilinear, the coordinates doesn't work. And Bruno Christoffel had already developed the symbols, so they built upon that work and created the covariant derivative, which works in any coordinate system. So it's coordinate free, and it is very, very important if you want to study the field of general relativity, or you want to work in differential geometry, any of those. Now, I can just say right off the bat, this book is excellent. Absolutely love it. One of the things is that on YouTube or maybe in some of your textbooks, you will see a little bit about the covariant derivative. This puts it all in one place. All right. So you can go from the beginning. Now you do obviously have to have already a knowledge of partial differentiation. That's important. Other than that, it's just normal calculus you're going to deal with. But he starts at the beginning. He goes through, he has some applications here, which are excellent. And he goes all the way up to this. The parallel transport, which was the concept originally, how Riemannian geometry came into life, was through this. Okay? And then he does some applications here. He's got the geodesics and the last one, the Riemann tensor from covariant derivatives. Let's look at that one specifically. Hello, are you going to work? Hello. There it is. Okay. So now he very thoroughly explains parallel transport, which I absolutely love this section because that is not an intuitive thing to understand. It's really quite tricky, but it's fundamental to your understanding of how this stuff, where this stuff comes from and how it's used. And then he introduces the Riemann tensor. Now, he does not do a derivation here. This is an exercise in Index Olympics. I've made a video of that myself. It's really long and tedious, but it's fun. Okay. And the part that's really key here to this section is he does an example. Now, this is the two spheres. So you're walking around on the surface of a sphere, and the radius is held constant. Okay, so this is intrinsic geometry, Riemannian geometry, which means it has a metric, and he gives the metric the tensor. He goes through. He shows you the Christoffel, the symbols. He uses the Christoffel, the symbols, to work out the covariant derivatives. And lastly, all the way down, you see what all he's done here. It's really, really good. I would highly encourage you to go through this line by line because you do learn a lot. He goes all the way down, bada bing, bada bong, and finally gets down to the answer and explains the answer. Now, I made a video of this myself, and I couldn't explain the answer, which I just love this. I love the way he explains this. He did a really good job. Okay. Now, I'm telling you, this this lesson in this book is almost by itself worth the price of the book because it really is good. I am so impressed with that. He did a very, very good job on this. I like this book so much that after he gave it to me and I read through it, I actually gave it as a gift to a fellow nerd, a young person. And you know, nerds rule the world, right? Everybody thinks it's something else. It's not, it's us. Anyway, this is a very good chapter in this book, and the book's already pretty good, but this one is outstandingly good. All right, I'll see you later.